Hello everyone. This is Chintan from Broadcom, and I have Vignesh and Kanan with me from PALC Networks. So I am mindful of the fact that this is the second day, and we have had a lot of technical presentations. So what we thought was, let's tweak it a bit. What we have done is not going to present. We'll kind of play a skit, right? And this skit is to actually demo one of the real life customers. It's an e-commerce customers use case that we have actually fixed using SONiC and Kubernetes, right? So we have named this customer as eshopping.com, and I am playing the role of a network engineer. I have with me Vignesh, who is the Kubernetes engineer for eshopping.com, and I also have my CEO with me. His name is Kanan. He takes care of our appraisals. So let's welcome Kanan on board.
Hi, I'm Kanan. I'm CEO of eshopping.com. We have built a great team to build a complete IT ecosystem for e-shopping to support millions of customers, to improve the customer experience and everything. So we adopted SONiC. So we have built a completely SONiC-based network infra, and we adapted Kubernetes on the server side. So we have a great team and great technology and great collaboration. So we wanted to go for the scaling options where we could plan for a mega sale. So that's how we have started. So since we have put in a lot of effort to build a team and the technology, stitching everything together. So we wanted to appreciate people spent a lot of time building the network infra and the application side. So we want to thank and appreciate our colleagues who have put in day and night to make things work. I'd like to call upon Chintan, who has been the best network engineer. Just wanted to get his challenges and how he did it, right? Yeah, thanks Chintan Chintan for making this network infra with SONiC to work. Just wanted to understand and share your insight on that.
Yeah, so we have built a network grounds up completely on SONiC, and the reason why we selected SONiC is because we know how well it scales, right? The best of organizations on the planet are using SONiC. We know that when we deploy something like this, which is open and disaggregated, we would have the choice of platform. So we would not be stuck with a particular OEM or ODM, and the programmability that it brings to the table is second to none. So that's the reason why I selected SONiC for my organization, which helped not only build a very robust, reliable network, but also saved a lot of dollars for eshopping.com. Yeah.
Great, Chintan. I think since we adapted open hardware and open SONiC, right? Just to acknowledge your effort, this is the token of appreciation. This is SONiC.
Thank you.
Yeah. Thanks, Chintan. Yeah. So next I want to call upon Vignesh, who has spent a good amount of time designing the entire scale of the system with Kubernetes. So Vignesh, would like to hear from you how you built it. What is the thought process behind Kubernetes and how does it work?
Yeah, when I joined eShopping and I saw how the system was built, it was completely a monolithic based architecture. And the first challenge I took it was completely break it into smaller pieces and bring in Kubernetes for the lifecycle management. And as we are eShopping and scale is an important factor, bringing in all the scale outs and scheduling is an important thing. That's where we feel Kubernetes is an important thing. And using Kubernetes now, I have built a very solid infrastructure. I'm not sure how this network people have built it, But from application side, I am very confident that the application will work very well and it will scale very well in all the problems.
Yeah, thanks, Vignesh. I think everything we can see tomorrow. We are going for a big day tomorrow. Just to appreciate your effort.
Thank you. Thank you.
Thanks. Yeah, I think today we have launched and our customers are logging in. I'm seeing it. Yeah, Chintan built a great network and Vignesh built a great Kubernetes. So why is it happening? I mean, a lot of transaction failed, checkout failures, close to 5 to 10% customers are not happy, they are dropping out. What should we do? I mean, it's going to be, how do I go to the board and tell that like I lost $1 million because the system is not working, customers are ready. Let me call Chintan and Vignesh.
Yeah.
Hey, Chintan, Vignesh, we have built a great ecosystem. So what do we do? Where are we missing? Can we guys figure out something?
Oh, I don't think it's a network problem. It surely has to be an application problem, right?
No,
you know,
always the problem is there on the network. We have built a awesome
hey man, around 650,000 nodes in Microsoft running SONiC. Do you think my SONiC would fail?
Where is the problem? I don't know. On a mega sale date, we see that its network is not working as expected.
Okay, why don't you explain me how your application works?
Okay, let me tell you how my system is. This is a sample deployment that we have in one of our data center. So we have around 32 racks, multiple racks, each rack having 16 servers. I have leaves going from each rack towards the tower, and I have spine, I have super spine. All this leaves and spine you guys have put it based on SONiC, and at least we have MC lag based deployments. And my applications, I have built it completely ground up from Kubernetes. And if you go to the next slide, I can show you whenever I want to scale during the auto sale. As we are an e-commerce site, we have search applications, we have product catalog showing applications, we have payment applications. All these are small applications which are driven by the Kubernetes. So based on the traffic load, I automatically auto scale, and wherever the servers are available, the CPUs and the memory is available, I put those applications on those nodes, and it scales really very well. And I have load balancers as well to make sure things are working fine. So this is how my applications are scaled and set it up. But still, I'm not sure why the issue happened on the day.
So you mean to tell that you provision workloads based on your compute health without asking me?
Yeah.
Okay, that's interesting. So do you know during our mega sale day, we had extremely high CPU utilization on leaf 1 and 2, which is 1A and 1B, right? And did you also provision your workloads on these servers which are connected to leaf 1A and 1B?
But you see there are a lot of servers there available which has the memory matrices from the CPU and memory perspective. At least I look at that, and based on that, I ended up deploying those pods on those servers. But I am not sure how do I go through the network things, because you have not told me like how to learn from the network.
Hey, I think let's stop bragging about great things which I am doing on my side and what you are doing on your side. I think we need to collaborate. We need to have an infrastructure which is aware, right? So before you provision, you need to take network health into consideration.
Okay.
Right? So what I'm doing is collecting a lot of information, right, using GNMI, and we have an internal process in the network team where we give an health score to the device basis the telemetry that we have collected. right? So why don't you do one thing? Let's have an adaptive scaling, right, where you take this health score of the network devices into consideration
Okay.
before you spin or before you scale out your applications, right? Why can't we do something like that?
Okay, are you talking about this design? So what I am going to do now is, I have a Kubernetes. Earlier I was just deploying pods. Now I'm going to, based on your input, what I'm going to do is I'm going to write my own custom scheduler, and you have to give me some APIs through which I can look into the network states, whether the leaf nodes are good, whether the spine node is good, what is the score, what is the health of the network. My custom scheduler will look into it, and based on that, let me see if it is able to spawn it on the right servers where there is no congestion, and we will see whether things are working fine.
Absolutely, we'll make the APIs available for you.
Okay, let's see a demo with the fix. So this is a sample which we use it in our internal processing, where we have a Grafana dashboards which are talking about the health scores that Chintan said, where it also calculates this health on particular nodes, particular interfaces based on various matrices based on which we have built, and this information is being used by the application layer to decide on which servers or which racks to place the pods. Probably we can run this video. So here we are going into the Kubernetes part. This is a very short video where we are just going to show that when the applications are being deployed without considering the network congestion, what's really happening, and once we see the congestion, and based on that, when we deploy, how things are changing. So just a short demo regarding that. So this is our custom scheduler, and I think now as a first thing, let's try to deploy probably a load balancer pod, Nginx based pod, without considering the network load, or when there is not much of networking load. And then after this, we will run some kind of AI applications. I think in this demo, we have run some BERT-based inference, and there will be some kind of congestion happening. After that, when you again deploy another pod, you can see that based on the network's intelligence, the pods are placed differently. So here we can see that the pod got deployed in the server 2 on rack 1, and we are running some AI workloads. The AI workloads are getting installed, the BERT client, BERT server, and we are running some kind of, say it's simulation. This is a simulation where there are multiple inference queries which are being sent, and those are also deployed in server 2 and server 3. The AI applications are installed in servers, and we can also see that there are multiple things, and the Grafana is able to detect that. It shows that, okay, there are some congestions which are really happening. Based on the scores, there are multiple factors which are being considered, whether it's early congestion or really congestion is really happening, and how good the network is. Now, after this, when a new pod gets deployed, or whenever there is an auto scaling which is happening, we can see that considering the network's health, the score, the new pod will be deployed on a different server. So now it got moved into server 4 instead of server 1. So if we want to see how we built the system, you can see that whenever the scheduling infra is called, it checks for, there is an external API which is being invoked, which checks, which is what the new application that we have written, which looks into the health of the status and decides where to place it, and depending on the scores it is placing it. And I think now, from now on, things will be fine. Let's hope for the best in the next sale.
Hey, this is awesome.
Yeah.
So, Vignesh, why don't we do one thing? I mean, we fixed the CPU side of the problem. Now we at eShopping are trying to build an AI cluster. And there is a lot more telemetry that I can get from the Broadcom silicon, right? When we are building the back end and front end. Can't we do something similar for AI workloads as well? What's your opinion about this?
Yeah, I see that you have all these PFCs, EZNs, watermark. There are various matrices that you are exposing. And probably as we are scoring it, we should consider those fields into when we are scoring the racks or switches. And based on that, I think I should be able to place the workloads. But if you see today, probably where they are using Kubernetes for inference, there is not, I'm not sure if it is really needed now, but in future where they're talking about inferences on multi-nodes, where we have to take the traffic across multiple nodes, I think this will be really useful. Let's use the same infra that we have built even when we move for the AI clusters as well.
That's great. So can we confirm to our boss that next time we have this mega sale, we will not see these kind of problems?
Yeah, let's call him.
Yeah. Thank you.
Yeah, thank you. Chintan, I'm just looking at like a workload. If you consider, like, say, humanize the workload.
Yeah.
Let's say when I start from my house, I look at the Google map. It shows red, green. Can we mark leaf spine somewhere?
Absolutely.
So that workload or the packet takes the green path, or
yeah, absolutely we can.
so that the operations become smoother.
Yeah.
Sure.
Hey, thank you.
Thanks.
Yeah. Any questions?
Really fantastic images from the side. So, hey, hi. I hope you got to keep your T-shirts, right?
Yeah.
Yeah.
That's a light note. Okay. So first thing first. So I can see you have used GNMI, and
Yeah.
in Kubernetes it is the kube scheduler which schedules the pod. So are you telling me that you're feeding that telemetry from the SONiC switches to somewhere into the Kubernetes ecosystem? And are you modifying kube scheduler? Just trying to understand a bit of internals there.
So let me try and give you the flow. So assume you have a leaf switch where the uplinks are congested, right? And they have been congested since the last 60 minutes. So, there is no point provisioning anything to the servers.
Absolutely makes sense. I mean, there will be a couple of servers. So let's say a switch has 30 ports, or let's say
48 ports. Yeah.
48 ports will only consider 40. So with redundancy, I'll consider 20 nodes.
Yeah.
So because one of the leaf switch, if it's a leaf pair, I'll say 20, a total of 40 servers across two racks, because you said it's star. So 20 nodes are pretty much useless because the network congestion is there, because the switch is there. Now, Kubernetes, the kube scheduler is now trying to scale out, right? So the pod is getting placed, has to be placed in a node which is not present in these 20 nodes.
Right.
How is the kube scheduler knowing that?
So what we'll do is we'll get from the LLDP data, we'll get which server is connected to which switch, and then we'll mark those servers as,
So you're actually cordoning those servers in a way, but you're not draining them.
Yeah.
So in a way, what happens is when your pod gets scheduled, the kube scheduler need not exactly know that the switches and the congestion, but rather it knows that those nodes are pretty much useless.
Exactly. Yeah.
It doesn't need to know the reason, just follow the instructions. Oh, cool.
Exactly.
So that's actually an easier way. I think you abstracted that out. Cool. Cheers for that.
Thank you.
Thanks.
Any other questions?
Okay. If not, then thanks a lot. Great presentation.
Thank you.
Loved it.